So let's just do an example real quickly, and then we'll continue on with a discussion of the subtleties of the mathematical logic involved here. So example number 1, let f of xy equal sine of xy, I should write this a little bit better here, equals sine xy and cosine xy. So that's our vector field. So this is our f and this is our g. Well, let's go ahead and find df dy and dg dx. So df dy is equal to x times the cosine of xy, and dg dx is equal to negative y times the sine of xy. Well, this and this are not equal, therefore there does not exist a potential function. In other words, this vector field does not have a potential function. So df dy not being equal to dg dx implies that there does not exist a potential function for this vector field f. This is how we use our test. Very, very nice. Okay. Let me go ahead and give you the analog for this in 3 space. So the analogous test for 3 space, now we're going to be talking about 3 variables, we just take them 2 at a time, is as follows. Okay, the same hypotheses, of course, and plus the partial derivative part of the test is, I'm going to write this in terms of capital D notation. d1 of f2 does not equal d2 f1. d1 f3 does not equal d3 f1. Again, this is where you have to be careful. d3 f1. Just take a couple of extra seconds to do this nice and slow. d2 f3 does not equal d3 f2. Okay. Then f of x, y, z, which is the first coordinate function f1, f2, f3. So here, instead of using f, g, whatever, I'm just using first function, second function, third function, does not have a potential function. So let's go ahead and talk about this notation a little bit more. I'm going to be using this one, but I'm also going to be using the other one. Okay, this says what I have to do is I have to check the derivative of the second coordinate function with respect to the first variable, and then I have to compare that with the derivative of the first function with respect to the second variable. The derivative of the third coordinate function with respect to the first variable, I have to check to see if it's equal to the derivative of the first function with respect to the third variable. I have to check the derivative of the third function with respect to second variable and see if it's equal to the derivative of the second function with respect to the third variable. The 3 variables are, the first, second, and third, respectively, are x, y, z. The 3 functions are f1, f2, f3. Okay? So this looks like, I'll go ahead and write out here, and I'll do this in blue. Let me see if I can get this right. This is going to be there's plenty of room. I don't need to squeeze it in here. Okay. This is d f2 dx does not equal df1 dy. This one is df3 dx does not equal df1 dz, third. And this one is df3 dy does not equal, excuse me, df2 dz. Take some time to look at this carefully. First, second, third variable, x, y, z. First, second, third coordinate function of the vector field. I'm mixing. Okay, so this sometimes, some people like this notation, some people like this notation. Just make sure that you pair up properly. This notation is nice because you have 1, 2, 2, 1, 1, 3, 3, 1, 2, 3, 3, 2. All the indices are actually taken care of so you can see that. It's just a question of getting used to this. You're probably not used to this too much depending on what notation your teacher uses. Okay,